Hello, Raven and
Hey,
Nikki.
hi guys.
Guys, I have good news. We'll be joining Kuala Lumpur Engineering Science Fair.
Wow, let's
Whoa!
go.
Yay! Oh, wait. Don't we have to prepare a video for that?
All right. Do you guys have any ideas?
Well, for starters, let's recap about our project.
Sure, let me explain it to you. When you think of cancer therapeutics, you'll probably think of chemotherapy and radiotherapy, right? Well, we are looking into a rising form of treatment and it involves apoptosis, which is the natural cell death that damaged cells go through. Apoptosis is promoted by proteins like caspase 9, but they are stopped by XIAPs, which cancer cells have a lot of. Don't worry though, we have something called SMAC, which promotes apoptosis by inhibiting these XIAPs.
Guys, that sounds really complicated. How can you explain this easier to the public?
Well, what if I put it like this? Imagine a stash of dominoes. Each domino is a protein that's needed for apoptosis, and when all of these dominoes fall, we have, wow, apoptosis. XIAP is the hand that stops caspase 9, but SMAC, well, SMAC's XIAP, allowing caspase 9 to fall and the cell dies.
Oh, that's a very great way to put it. Because of that, there are drugs called Smac Mimetics that mimic Smac to promote apoptosis.
Yes, and that's what we tried to create. Our objective is to create designs of novel Smac Mimetics. These could possibly become additional cancer treatments.
But what's the point again? Aren't there already cancer treatments existing?
Yes, there are, but not all types of treatment work on all cancer cell lines. That's why it's important to have a variety in cancer treatment. Also, creating Smac Mimetics will help us learn more about them for the benefit of future studies.
Hey guys, sorry for making you wait. I spilled water and had to change my shirt.
Hey, that's a great analogy!
What?
So imagine the receptor is you. The shirts you are trying on are the different ligands that we created. We basically looked for the shirts that fit you the best.
Oh, so that's molecular docking, right? I remember us using binding affinities. How can we explain that?
Imagine there's a measurement for how well your shirts fit you. That's binding affinity. The stronger the binding, aka the better your shirt fits you, the higher the binding affinity.
Here, we designed our compounds. We used SM130, a known Smac Mimetic, as the base ligand and added modifications to this.
Using autodock tools, we made our compounds and the receptor flexible.
We used autodock vena to determine the binding affinity given in kilocalories per mole.
In Pymol, we were able to choose what's the most appropriate binding pose amongst all the possible ones. We checked the interactions of the ligand and the receptor, and we also compared our chosen pose to the ideal pose of SM130. We finally used Swiss ADME to check drug likeness using Lipinski's rule of 5.
What a ride that was last year! We tried so many different designs that would fit a receptor, right?
Yeah, we modified the base ligand SM130, which has a binding affinity of negative 7.2 kilocalories per mole in 4 areas. And we ended up with 6 good ones. I think I have a picture of them. Hold on.
Yeah, compound 14 was the best compound that we made. It increased the binding affinity to negative 8.6 kilocalories per mole.
That's true, but the other compounds were also pretty good, like compounds 5, 10, 12, 16, and 35, that increased the binding affinity to at least negative 8.0 kilocalories per mole. They all also qualified in Lipinski's rule of 5.
Wow! So we basically cured cancer, right?
Whoa, stop right there. Have you forgotten?
Forgotten what?
There is so much left to be done in order to say that we created a cure for cancer.
Right, so much more testing needs to be done on these. We only have their computational binding affinity to show their potential. Hopefully, these compounds can be synthesized and tested further.
Agreed. Anyway, guys, I think it's getting late.
Yeah, it's getting quite dark out here.
Well, looks like we're all ready for Kuala Lumpur. Bye!
Bye!
Bye.